we had talked previously about Lewis dot structures. Do you remember me talking about those? And how we count those up. If we're in the first column, we've got 1, second column 2, and that applies to that whole section, and then 3, 4, all the way until you get over to 8. Do you remember that? Okay, so you're going to have to be able to count those today and know how many valence electrons you're working with. So everybody's comfortable with figuring out the Lewis dot structures that we had earlier this year. Okay. So now what we're going to do is we're going to combine these and make covalent compounds. Okay. So for a Lewis structure, the atoms you're going to connect to form a molecule. A line or a pair of dots represent a single covalent bond. 2 lines or 4 dots are going to indicate a shared pair of electrons. So for example, if we had fluorine, this line would indicate that these 2 fluorines are attached to one another. This is what 2 oxygens would look like. And this is a triple bond, and that is what 3 nitrogens or 2 nitrogens would look like with a triple bond. Okay. You also have things called lone pairs of electrons. So they're going to form in pairs, and they're going to complete your octets for these. Because we're going for a magic number of 8 unless we're dealing with hydrogen. Hydrogen only has 2 total. Okay, so this is what those lone pairs of electrons look like. So here we have 2, 4, 6, and then this bond would be 8. So that fluorine would end up having 8 electrons around it because it's sharing an electron from this fluorine. This oxygen would have 2, 4, 6, 8 because it's sharing electrons from that oxygen. And then the same thing, we could count those up for the nitrogen. So this is what they're talking about in terms of these lines. This is a single bond, a double bond, and a triple bond. Okay, makes sense? All right. So when you are doing a Lewis dot structure, you're going to count up the total amount of valence electrons in terms of the different atoms that you're dealing with. You're going to draw a skeleton structure where you single bond everything together. And then you're going to find a way to make your octets except for hydrogen. Hydrogen is going to only have 2 electrons to be stable. Hydrogens and fluorine, okay, are always on the end because they can't accept any extra electrons. Elements in the 3rd period and 4th, 5th, 6th, and 7th periods are capable of expanding their octets so that they can actually have more than 8 electrons around the central atom. And I'll show you some examples of that later today. Placing remaining electrons as lone pairs until you fill the octets. And then if you run out of electrons before filling, that's when you're going to do double or triple bonds. Okay? The best way to do this is to actually show this happening. So that's where I want to get to some of these. Okay? Boron is also a special case. It's going to be an incomplete octet. It is satisfied with 6 electrons. Okay? All right. So let's get started here. We are going to draw the Lewis diagram for this. So the first thing that they said to do, we had to count up how many valence electrons we had. So I have my hydrogen over here. Then I have my carbon over here. It is in column 14. This is in column 1. And I have my column 17. I have fluorine, and then I have chlorine here. Okay, so I'm going to count on my periodic table. 1, 2, 3, 4, 5, 6, 7. So chlorine is going to have 7 valence electrons. So it has 7. Hydrogen has how many? 1. And I have 3 of them. So 1 times 3 is 3. And carbon has 1, 2, this is 13. So 1, 2, 3, 4 for carbon. But I have 2 of them. So how many do I have? 8. Okay. We are going to add these up, and that's how many electrons we have to work with. Oh, I didn't give you guys your packet. What am I thinking? Nathaniel, you got to keep me on point.
I got
You have your sling off today.
Yeah.
Feeling better? Huh?
A little bit.
Good.
Thanks, Frank.
My fault with the make sure you pass it out.
Yeah, I'm just off my game today, I guess. I don't know. At least I didn't spill my coffee everywhere.
Yeah, that's a good start.
What better than yesterday? I broke yesterday.
I had a rough day.
All right, let's try this again. So, y'all found where I'm at now? Second page, I think we're at. I'm drawing this guy.
Third page.
Third page? Wow, I zoomed right through that.
What are we doing? Is this due tomorrow?
Yeah, yes.
1 through 4?
Yeah.
I got 1 through 8.
Yeah. You should be on this one now, though. This is what we're working on.
Yeah, I am on that one.
Okay. All right. So, I've got how many electrons to play with here? 18.
Great. Oh.
7 and 3 is 10, right? 10 plus 8 is 18.
Yeah.
Do you know where I got them all from? Okay, I'm going to go through it again so you pay attention to this one. So my carbon here, we're going to count on our periodic table. 1, 2, 3, 4 valence electrons for carbon. Okay, I got 2 of them. So 2 times 4 is 8.
Oh. Okay,
Hydrogen's in the first column. It has 1 valence electron, but I've got 3 of them. 3 times 1 is 3. Chlorine is in the 7th column. When we count over 1, 2, 3, 4, 5, 6, 7. So it has 7, but I've only got 1 of them, so that's 7. So then I add all those up. 7 and 3 is 10. 10 and 8 is 18. So I've got 18 electrons to play with. Now, 99.999% of the time, the element that's listed first is going to be your central element. So start by putting that down. So we're going to put our carbon down first, and we're going to connect it to the second carbon here. Okay? Then these things, we know the hydrogens have to go on the end. So we're going to do a hydrogen here, a hydrogen here, and a hydrogen here. That's not going to work. All right, I'm going to put my chlorine here, and I'm going to show you why that doesn't work here in just a second. Okay, so I've got my chlorine here, 2, 4, 6, 8, 10. I still need to finish this out. 10, 12, 14, 16. Okay. So my chlorine has 8. My hydrogens all have 2. this carbon has 4, but this carbon here only has, each line counts as how many?
4.
So it has 4. I need to get it to 8. Okay. Now, I can't double bond it here with the current way that this is done because this carbon is already at 8. Okay. So what I'm going to do is I am going to take one of these hydrogens and I'm going to put it here on this carbon. Now I'm going to count up how many electrons I have. 2, 4, 6, 8, 10, 12, 14, 16. I still have 2 electrons that I need to place. I also have this carbon that's only at 6 and this carbon that's only at 6. So what can I do? What do I say for the last step if we ran out of lines? Double bond. Okay. So I'm going to double bond right here. Then that's going to give this carbon 2, 4, 6, 8. It's going to give this carbon 2, 4, 6, 8. It's going to give this chlorine 2, 4, 6, 8. And each hydrogen has 2. Is that okay?
Yeah.
Makes sense? Yeah? All right. So that's our first one here. Questions on that? All right. So let's draw some more here. All right. Let's see. We're going to count up how many lone pairs of electrons we have here. So my carbon, how many does each carbon have? 4. I count my columns over. 1, 2, 3, 4 for carbon. I have 2 of them, so that is 8. And my hydrogens have how many? 1 each, and I've got 2 of them, so that's a total of 2. So I have 10 electrons at play here. I'm going to start by putting my carbons in the middle, and I'm just going to put a hydrogen off, 1 on each side to kind of balance it out. Now, how many electrons have I placed at this point? 6. I have 10 at play. Hydrogens can't get any more. They can only have 2 ever. So I've got to deal with this. So what am I going to do here to get these things at an octet and use up all 10 electrons? Right, I'm going to have to triple bond here. So that's going to give me 2, 4, 6, 8 for this carbon, and 2, 4, 6, 8 for this carbon. I go back and make sure that I've used up all my electrons. 2, 4, 6, 8, 10. I've used them up. I haven't, left some off, and I haven't, used too many. So we are sitting at that good spot right there. Okay. All right. Now let's talk about this next guy. Do you see how this has a little line here? That indicates that this is a polyatomic ion. This has a charge associated with it. What is this called? Does anybody remember? It's an anion. Yep. Well, what's its name? Hydroxide. Yep. Good job. You guys kind of remembered that from before. All right. So we are going to count up our electrons. Oxygen has 6. Hydrogen has 1. And then this negative sign right here is going to give us another 1. So that's a total of 8 electrons at play here. Okay. So here is my line that is 2 electrons connecting these. I can't add any more electrons to hydrogen. It can only ever have 2. I need to fill up my oxygens with lone pairs and get that balanced out. I also need to indicate to my audience, whoever's reading this, that this was an ion. And the way it's drawn right now, they wouldn't know that. Okay? So the way you do that is you use square brackets to surround it, and then you're going to put whatever charge it is up in the corner here. So that indicates to your reader, whoever's looking at your material, that this has a negative, an extra electron at play that we've put in that structure. Okay? All right, let's do the next one. We've got chlorine. We have 2 fluorines and a sulfur. I'm sorry, not chlorine, a carbon. So how many electrons does carbon have? 4. I have 2 fluorines, and each fluorine has 7. 7 times 2 is 14. And then I have sulfur. How many does sulfur have? 6. Okay. Again, you're counting the columns that these are in. So 1, 2, 3, 4 is where your carbon is. 5, 6, 7, 8. Your sulfur then is down here, and your fluorine is up here. Okay. So that's where we got those values when we're counting here. What's going to be my central atom? Carbon. Fluorine can never have more than one thing attached to it under any circumstances. So you're not going to put fluorine in the center because nothing can come off of it except one thing. All right, so I'm going to put chlorine here. Then I'm going to put my fluorines out, and I'm going to put my sulfur out. All right. I need to count up how many electrons I have. I'm going 24. Anybody confirm that? Yeah. Okay. So right now I've got 6 of 24. So 6. I'm going to start doing my octets. 8, 10, 12, 14, 16, 18, 20, 22, 24. What is wrong with the structure as I have it drawn right now? Carbon doesn't have all 8. Okay. Fluorine cannot double bond ever. Can only single bond. So what we're going to have to do, we ran out of electrons here, didn't we? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Yeah, we ran out of electrons. I don't have any more to place. So I'm going to have to take this lone pair down here and bring it in as a double bond. Do I need square brackets around this? No, because it doesn't have a charge. All right. Any questions on that one?
Are these not like the bunk beds where they all have to be filled up? It could go like anywhere. Like, because I thought instead of taking the 2 from the bottom, we take 1 from the side and then 1 from the bottom.
But you can't. Yeah, they need to be doubled up. You need to have these as pairs. Yes? Okay. All right. Now, the next one here is boron. Okay. Boron is located right here next to carbon. So it has 3. My chlorines have 7 each. So chlorine is right here. They have 7 each. And I've got 3 of them. So that's a total of 21. 3 and 21 is 24. I'm going to put my boron here, and I'm going to connect my chlorines off of my boron. Okay. So at this point, I have 6 electrons placed. 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay. What do you see any problems here?
Is boron filled?
It's already filled.
Okay. So boron has 6 around here. But remember back here, I said that boron can have an incomplete octet. So the incomplete octet means that boron is satisfied with 6 electrons around it. It is a special case. As far as I know, boron's the only one out there that's special like that. Okay. The next one then we're going to talk about is sulfur. So sulfur has 6. Fluorine has 7, but we've got 6 of them. So that's a total of 6 times 7. 42. And that gives us a 48 total to be able to play with. All right. Now, let's talk periodic table here. When we looked at our periodic table, we had our hydrogen and our helium here. We had our lithium, beryllium here. We had our boron, carbon, nitrogen, oxygen, fluorine, neon. Then we went down here to sodium and magnesium and yikes. Aluminum. Yep, that's it. Aluminum, then silicon, phosphorus, sulfur, chlorine, and then argon. And then we went down here. We did K and Ca. And then we went to Se. And we had this section right here. And this is what I'm after right here. This was what orbital? 3D. Okay, so this is your 3D orbital here. That 3D orbital is in what level? 3. What level is sulfur in? 3. So sulfur can actually tap into and expand into this 3D orbital when it's bonding. Okay, so anything that's aluminum and higher can expand its octet into the D level. So it can have an expanded octet. We can make it bigger. And that's what's going to happen here with this sulfur. Sulfur is going to be in the middle, and it's going to have 6 things coming off of it. 6 of these fluorines coming off of that sulfur. Right now, I have how many electrons placed? 12. 12 out of 48. 14, 16, 18, 20, 22, 24, 26, 28, 30. Put that on the wrong side. 30, 32, 34, 36, 38, 40, 42, 44, 46. 48. That's a lot of dots. And that's how we expand sulfur's octet. Now, you've got some on there that you're going to work with and try to draw. You might come up with slightly different structures than what I have. Okay. And that's okay at this point. Tomorrow, we are going to look at something called formal charge, and that'll get us all on the same structure. But for today, you're just practicing. Okay. And you're going to see if you can get the same structures that I have, but you might end up with a little different today just because I haven't taught you formal charge yet. Yeah.
So is sulfur the only one that can have all?
No. Nope. Nope. So anything sulfur, phosphorus, chlorine, they can all expand their octets.
Just bigger than aluminum?
Yep.
Okay.
Yep. Because that's the aluminum is the one. Well, magnesium and sodium and probably aluminum even. I would even say aluminum probably wouldn't either because they're probably going to be anionic compounds. But anything that's a non-metal, so sulfur or silicon all the way up, anything that's a non-metal is going to be able to expand its octet.
Okay.
All right, I don't think I have the answer key for this uploaded yet, so I need to get that done for you guys.
Yeah.